Hello everyone, I am Suman Kiro and today we shall learn isomerism in coordination compounds. In your 11th class you might have studied different types of isomerism in organic chemistry. Okay, in general isomers are the compounds which have same molecular formula but different structure. And in organic chemistry you might have studied under structural isomerism, chain isomerism, position isomerism, functional isomerism and metamerism. And in geometrical isomerism you might have studied cis and trans isomerism. Okay, so in a similar way the property of isomerism is also found in coordination compounds, but here the concept is little different. Okay, we'll try to understand them. In case of structural isomerism, we had four types of isomerism in coordination compounds: ionization isomerism, hydrate isomerism, co-ordination isomerism and linkage isomerism. Okay, we'll try to understand them one by one. First of all, let us understand what isomerism is in case of coordination compounds. The coordination compounds which have same molecular formula or chemical composition but different structure or spatial arrangements are known as isomers, and this phenomena or this property is known as isomerism. Okay, in coordination compounds also there are two types of isomerism. Okay, structural isomerism and geometrical isomerism. Okay, today we shall learn only about structural isomerism. Okay, in structural isomerism, the coordination compounds have same molecular formula or chemical composition, but they differ with respect to structure. Okay, so there are four types of structural isomerism that is shown by coordination compounds. First one is ionization isomerism. Okay, so the molecules or the coordination compounds which have same chemical composition but give different ions in their aqueous solutions are known as ionization isomers, and this property or this phenomena is called ionization isomerism. Okay, same thing I have written here. The coordination compounds which have same chemical composition but give different ions in their aqueous solutions are called ionization isomers, and this property is called ionization isomerism. For example, CONH3 5 times BrSO4. Okay, pentaamine bromido cobalt 3 sulfate and pentaamine sulfato cobalt 3 bromide. It is an example of ionization isomerism. Okay, how do they get ionized in their aqueous solutions? If you make an aqueous solution of this compound pentaamine bromido sulfate, then it will be broken into CONH3 5 times Br2 plus aqueous plus SO4 2 minus. Okay, so pentaamine bromido cobalt 3 sulfate will be broken into pentaamine bromido cobalt 3 ion and sulfate ion. Okay, and CONH3 5 times SO4 Br. Okay, this will be broken as CONH3 5 times SO4 plus, okay, AQ plus Br minus AQ. So we find that when we make aqueous solutions of these complexes, they are broken into different ions. So this type of coordination compounds which give different ions in their aqueous solutions are referred to as ionization isomers, and this property is called ionization isomerism. Okay, let us see the next one. Okay, next one is hydrate isomerism. Okay, second one is hydrate isomerism. Hydrate isomerism. Okay, so the coordination compounds which have same chemical formula but have different number of water molecules used as ligands are known as hydrate isomers, and this property is called hydrate isomerism. So what are these? These are the coordination compounds, okay, coordination compounds which have same chemical composition, okay, same chemical composition but differ with respect to the number of water molecules used as ligands. Okay, you and add after that are called hydrate isomers, and this property is called hydrate isomerism. Okay, so the coordination compounds which have same chemical composition but differ with respect to the number of water molecules used as ligands are called hydrate isomers, and this property is called hydrate isomerism. For example, CrH2O 6 times Cl3. Okay, hexa aqua chromium 3 chloride, and CrH2O 5 times, okay, one Cl will go inside, okay, Cl2 H2O. Okay, similarly you can get some more formulae. CrH2O 4 times Cl2 H2O. So these have same chemical composition. Here the number of water molecules used as ligand is 6. Here it is 5 and here it is 4. So such coordination complexes which have same chemical composition but differ with respect to the number of water molecules used as ligands are called hydrate isomers, and this property is called hydrate isomerism. ओके, चलिए इसको नोट कर लीजिए, उसके बाद आगे देखेंगे. Okay, the next one is co-ordination isomerism. Okay, this type of isomerism is found in those complexes in which the complex contains both cationic and anionic complex. Okay, in such complexes the counter ions, so to say, are also complexes, and in such complexes, okay, they differ with respect to the distribution of ligands with the central metal ion. Okay, it is found in those cases in which the complexes contain both cationic and anionic complexes, and the isomers differ with respect to distribution of ligands. For example, CONH3 6 times and CrCN 6 times. Okay, these behave as one complex. So here it is cationic complex, it is anionic complex. Now its isomer, in its isomer, there will be an exchange of ligands. Cyanide will come with cobalt and NH3 will go with chromium. So we get COCN 6 times and CrNH3 6 times. So in such complexes, okay, this type of complexes in which there is, in a single complex there are two complexes, cationic and anionic complexes, and in such complexes the distribution of ligands with the central metal ions differs. And here in the first complex we have NH3 with cobalt, in the second we have cyanide. Okay, in the first with chromium we have Cn, cyanide, but in the second isomer we have NH3 with chromium. So like this, there is a difference in the distribution of ligands with the central metal ion. Okay, let us see the last one, linkage isomerism. Okay, linkage isomerism. Okay, linkage. So actually this type of isomerism is found in those cases in which ambidentate ligands are involved. Okay, ambidentate ligands. Okay, ambidentate ligands are the ligands which have two donor atoms, but only one can coordinate with the central metal ion at a time. And therefore, when such ligands are involved, then we get linkage isomerism. So you can define this as the co-ordination compounds. Okay, the co-ordination compounds which have same chemical composition. Okay, same chemical composition, but differ with respect to the linkage made by the ligands with the central metal ion, central metal ion, okay, are called linkage isomers, and this property is called linkage isomerism. Then one more line you add. Okay, this is found in case of ambidentate ligands. Okay, ambidentate ligands. Okay, let us understand this with an example. Okay, suppose we have CrNH3 5 times NO2. Okay, NO2, Br2, and CrNH3 5 times BR2. Okay, this is an example of linkage isomerism. Here the linkage is between chromium and nitrogen. Okay, so its name is pentaamine nitrito-N chromium 3 bromide. Okay, here the linkage is between chromium and oxygen. Okay, so its name is pentaamine nitrito O chromium 3 bromide. Okay, similarly you can write, okay, cobalt H2O 5 times Cn, okay, Cl2, and CO H2O 5 times Nc, okay, Cl2. So here carbon will make bond with the central metal ion cobalt, okay, cyanide of carbon, and here in this complex the bond will be between cobalt and nitrogen, not between cobalt and carbon. So this type of isomers are called linkage isomers. Okay, and this phenomena is found in those cases wherein antidentate ligands are involved in the complex formation. Okay. Okay, so enough for today. In the next class, we shall learn geometrical isomerism in coordination compounds. Okay, cis trans. Okay, and facial and meridional. All these concepts we will learn in the next class. Bye.